Alright, so this video I'm going to cover x-intercepts, which are also called zeros, of rational functions. So we've talked about x-intercepts a lot in your past math classes, in the first semester of this class. So you should be familiar with what an x-intercept is generally. So for example, if we had a linear function, y equals, let's say, 2x plus 4. If someone were to ask you what's the x-intercept of this function, what they're really asking is what value of x makes the whole function equal 0. So what they're really asking is what is the solution to this? 0 equals 2x plus 4. So then you can just solve that. So you get negative 4 equals 2x, divide both sides by 2, and you get negative 2. So this is your x-intercept, or your 0 of the function. So, in other words, negative 2, when you plug it in, it'll give you 0 out. So then we've also talked about x-intercepts of quadratic functions. So we had like f of x equals x squared plus, what should we do? We'll say 4x plus 3. Then if you want to find the x-intercepts, well, we start by writing 0 equals x squared plus 4x plus 3. We can factor this. So remember, we want to figure out what two numbers multiply to 3 and add to 4. So it's going to be x plus 1 and x plus 3. And remember, you could have the 3 here and the 1 here. It doesn't really matter. So now we can see that to get 0, either this guy has to be 0 right here, the x plus 1, or this guy has to be 0, the x plus 3. So we have either x plus 1 equals 0 or x plus 3 equals 0. So that gives us x equals negative 1 or x equals negative 3. So that was a really quick review of what we know so far about x-intercepts before this unit even started. So now let's look at x-intercepts of rational functions. So let's say we have, we'll say g of x equals, let's say, x plus 3 over x minus 2. Let's just do something like that. All right, so now the same idea as with the other types of functions. The x-intercept is just what value of x makes the function equal 0. So what makes x plus 3 divided by x minus 2 equal 0? So you want to find the solutions to that. All right, and if you think about division and fractions, if we have a fraction that equals 0, really all that means is that the top is 0. We don't really care what the bottom is, as long as the bottom's not 0. So as long as the bottom's not 0, we don't care what it is. So we can kind of just ignore it. So that means we just want to figure out what makes x plus 3 equal 0. And that is x equals negative 3. So that is our x-intercept. And that just means that on the graph, it's going to cross the x-axis at x equals negative 3. So the important thing here is to not get thrown off by the fact that it's a rational function. It's really not any different from other functions. You just have to remember that you can ignore this bottom part completely as long as it's not 0, as long as you don't have the bottom equaling 0 at whatever you get your x-intercept, which you really shouldn't. That really shouldn't happen. So yeah. So let's do another one just for the sake of practice. Let's try h of x equals, let's try, well, this will be a good one. Let's try 1 over x plus 2. Our question is, what is the x-intercept, or what are the x-intercepts of this function? So we want 1 over x plus 2 to equal 0. So we want to figure out what value of x makes that 0. Actually, but in this situation, there's nothing we can plug in to x that will make it 0. So no matter what we plug in, we can plug in 1, we'll get like h of 1 will give us 1/3. H of 10 will give us 1/12. If you plug in a negative number, h of -10, we'll just get negative 1/8. So nothing we plug in where x is going to make the function equal to 0. So there actually are no x-intercepts in this situation. And that's actually the same as saying that there is a horizontal asymptote. And there will be a video about horizontal asymptotes as well. But just to make some connections between concepts here, there's going to be, if there's no x-intercepts in the rational function, that may mean and probably will mean that there's a horizontal asymptote at y equals 0. So that just means that the graph never crosses the x-axis. So it would look something like, and I'm just going to sketch it out generally so you get the idea. It'll look something like that. So it's never going to cross here. There's going to be a little line here that flattens out down here and never crosses down this way. And there's going to be another one that flattens out this way. It's never going to cross this way either. So that's kind of what's happening there. All right, now let's try another one where we actually are going to have some x-intercepts. So j of x, let's say j of x is x squared plus, let's do 6x plus 9 over, let's say, x minus 8, let's say. Okay. Now, remember, we really don't care what's on the bottom, because no matter what's on the bottom, if the top is 0, then the function is 0. So we just want to figure out, how can we get x squared plus 6x plus 9 to equal 0? And if we think back to math 2, we can figure that out by plugging it, or not plugging in, by factoring. And if we factor, we're going to get x plus 3 times x plus 3. So x is going to equal -3. So that's our x-intercept. All right. So the important thing with x-intercepts in rational functions is just to remember it's really no different from finding x-intercepts in any other kind of function. You just have to understand what an x-intercept really means, like what it means to have an x-intercept at a certain point, and you should be good to go. So hopefully this was helpful. Just don't overthink it, and I'll see you in the next video.